This is video homework for Tim Barron, Physics 350. This is problem number 9 from chapter 1. We're given an electric field that equals C times R vector over R squared, and we're asked to calculate the divergence and curl, test with the divergence theorem, and find the units for C. So to solve for this problem, we're going to use the formulas for divergence and curl, and I decided to mix it up a little bit and use spherical coordinates to solve for the divergence and rectangular coordinates to solve for the curl. The formulas are listed right here, and I'm expecting to find the curl of the electric field to be 0 since it is an electrostatic field. Then to test the divergence theorem, I'm going to use the formula listed here. To find the units of C, we're going to analyze the equation. So to solve for the divergence in part A, we're going to go ahead and look at the formula. We're going to substitute in r hat times r for r vector, and that will give us our r hat component to use in this formula. There's no theta and no phi, so we don't have to worry about that. And once we plug it in, you can see that we end up with C over R squared as the final answer for the divergence. To solve for the curl in part A, we first need to substitute in the vector value for R vector and R in rectangular coordinates. And once we do that, you'll see what we get here for E in rectangular coordinates. We've got the x hat, y hat, z hat coordinates. Then we need to use the formula listed above, and we need to take a whole bunch of derivatives, which ultimately leads to this being 0, which is what's shown at the bottom, and that's what we were expecting here. So for part B, we need to test the divergence theorem. You can see the equation that we're going to use for that up on the top. We've got d tau, we've got here in the upper right, and then we've figured out dA, also a little bit lower than that in the upper right, and we're going to need to use those to complete the integral on both sides. And we're going to use a sphere for ease of calculation, and using the limits for theta from 0 to pi and phi from 0 to 2 pi. You'll see as we do the triple integral and the double integral as we get to the bottom, they both come out as 4 pi ck, so it passes the test of the divergence theorem. To solve for part C, we know we need to end up with newtons per coulomb, and we can see that the units of the given equation are actually C over m. So in order to make that work, we need to use kilogram meters squared over second squared all over coulombs to be C to make this work. I learned how to calculate both the divergence and the curl and verified that the curl was 0, which is what I was expecting. I also learned how to use the divergence theorem. What I learned the most about was how to calculate the infinitesimal elements for doing the divergence theorem.